Let's begin with 2 times e to the 5x minus 5 times e to the 2x minus 12 times e to the negative x equals 0. I want to solve for x. So the first thing to notice is that each of the terms has e to some power of x. So I'm going to factor out one of these e to the exponents, and then I'm going to try to factor it even further. So the key here is to factor out the smallest exponent. So the candidates are 5, 2, and negative 1. Always factor out the smallest one. So we'll have e to negative x outside. And to get to 2e to the 5x, we'll need 2e 6x. Because when we multiply, we add the exponents. And to go from negative x to 2x, we need a positive 3x. And then the last one is just minus 12. At this step, we see that the exponent here is twice the exponent of that. In this case, this is a quadratic in disguise. So we can say we can let that equal e to the 3x. So what's in parentheses now becomes 2u squared minus 5u minus 12. And now we can factor this nicely as 2u plus 3 and u minus 4. From here we can substitute back. So we will put in 3x for u, for x. 3x for u. Okay, and then we'll have e to the negative x, so this guy just comes down. Set that equal to 0. The last step is to set each one of these factors equal to 0. E to the negative x, well, e to the negative x looks something like this. You can think of this as exponential decay. This will never be 0. There's an asymptote at 0 here, but we'll never reach it. So it's never equal to 0. The next one, we have e to the 3x equal negative 3 halves. For this one, e to the 3x looks something like this. Again, it doesn't reach 0, and it certainly doesn't go below 0. So this is always positive, therefore it cannot be negative. The last one, we have e to the 3x equals 4. So x is equal to ln of 4 over 3. And this is a nice, perfectly number. So that is our final answer.